I'm Peter Kwiecinski, and this is an article by Robert Lemoyne and Timothy Mastroianni talking about advanced concept ramjet propulsion systems using antimatter created from ultra-intense lasers. So with the recent ability to create antimatter, there have been numerous tests, like at the Lawrence Livermore National Lab, which used an ultra-intense laser on a 1 mm gold target to create 2 × 10 to the 10th positrons. The article talks about 2 different processes for creating antimatter: the Trident method, which is a 1-step process, and the Bethe-Heitler method, which is a 2-step process. The Trident method involves throwing an electron into nuclei to create electron-positron pairs, and the Bethe-Heitler process involves exciting electrons to release high-energy photons, which they can also throw into nuclei to create electron-positron pairs. The Bethe-Heitler process is more prominent because it creates more positron pairs given the size of the gold target. The ramjet is also talked about in the article, which is a jet turbine and basically how most planes fly, which is as the plane moves forward, ambient airflow is thrown into the turbine, which is then injected with fuel, and it is combusted and thrown out the other end, which creates static thrust. This process is isentropic, which means that as energy is put in, it is the same energy that comes out. So ideally, there is no energy loss. So the theory is that energy for the propulsion can come from antimatter collisions rather than the jet fuel itself. So ideally, the antimatter ramjet would allow the fuel-air ratio to be 0, since the fuel could be infinitesimally small compared to the airflow. And so what they did is they used math, and they found thrust as a function of airflow, and they plugged in the energy balance of antimatter equation into that, and they were able to calculate basically how this could possibly work. So this implies that as technology advances and lasers become more powerful and more compact, it could further antimatter studies. Basically, we could create more positrons with the lasers. And with that, we may be able to use UAVs, unmanned aerial vehicles, and we may be able to decouple the power source from the propulsion, which would advance plane technology, as the power source could now come from the ground, say a power plant, while the propulsion can stay on the plane. So what this means is that the fuel no longer needs to stay on the plane, and planes can be built without it, making them both lighter and faster. And an important note is that while this may seem impossible currently, it wasn't until the 1700s that the first flight schematics showed up. And the first flight wasn't until 200 years later, the 1900s. And it was only 40 years later with the first supersonic flight. So while it may seem out of reach, it certainly seemed out of reach in the 1700s and the 1900s compared to supersonic flight and regular flight. So it may not be entirely impossible. But still, there are limitations, such as the radiation from the antimatter collisions. We still don't know how that affects things. Flight optimization for the planes, and there still need to be large improvements in laser technology to create the antimatter needed for these types of propulsion power source systems. And so that was basically the article, and it talked about how ramjet propulsion systems can use antimatter.